Next is the smart objects. Smart objects, we can say that IoT enabled connected devices. Imagine that you have a IoT enabled connected vehicle and roadways highlighted in the whatever we have studied in the previous chapter. Say for example that car has an impressive ecosystem of sensors that provides an immense amount of data that can be intelligently copied. Okay, so now that data which we are going to extract from the consumed by variety of systems and services and the car itself as well as shared externally with other vehicles. Okay, the connected roadway infrastructure or even a whole host of other cloud-based diagnostic and the consumer services. Okay, from behind the steering wheel, almost everything in the car can be checked, sensed, and controlled by some devices. Those are called as sensors. The car is filled with sensors of all types. For example, we can say you may have temperature sensor, location sensor. Okay, then that is we can say GPS pressure. That is which we are going to check the wheels, air, right, velocity, that are meant to provide a wealth of rich and relevant data among many other things, which are going to improve the safety and simplify the vehicle maintenance and enhance the driver experience. Okay, now in this smart objects, right, or physical objects that contain embedded technology to sense or interact with other environment in a meaningful way by being interconnected, enabling the communication among themselves or an external agent. Such sensors are fundamental building blocks of IoT networks. In fact, they are the foundation elements found smart objects. We can call them as things in the Internet of Things, right? And smart objects are any physical objects that contain embedded technology to sense and or interact with their environment in a meaningful way by being interconnected and enabling a communication among themselves or an external agent. Okay, so this module 2 sub chapter is going to provide the detailed analysis of the smart objects and their architecture. It also provides an understanding of their design limitations, role within the IoT networks, specifically the some of the fundamental building blocks of IoT networks are sensors, actuators, and smart objects. Second is the sensor networks. Okay, so these sensors, actuator, and smart objects defines the sensors, actuators, and smart objects and describes how they become the fundamental building blocks of your IoT network. Okay, so let me take one by one. That is first we will take a sensors, right? A sensor does exactly as its name indicates. It senses. More specifically, a sensor measures some physical quantity and converts that measurement readings into digital representations. Okay, that digital representation typically passes to another device for transformation into useful data that can be consumed by intelligent devices or humans. Naturally, so these sensors are limited to human-like sensory data. A parallel can be drawn with humans and use of their five senses to learn about their surroundings, like human beings having the five sense organs where they are going to sense their functionalities. Human senses do not operate independently in cells. Instead, Instead, they complement each other and compute together, empowering the human brain to make intelligent decisions. The brain is the ultimate decision maker and it often uses several sources of sensory input to validate an event and compensate for incomplete information. Sensor limited to human sensory data, not limited to human like sensory data. They can measure anything worth of measuring. In fact, they are able to provide an extremely wide spectrum of rich and diverse measurement data with far greater precision than human sensors. Sensors provide a superhuman sensory capabilities. This additional dimension of data makes the physical world an incredibly valuable source of information. Sensors can be readily embedded in any physical object that are easily connected to the internet by wired or wireless networks, because these connected was physical objects with a multi-dimensional sensing capabilities communicate with each other and external systems. They can interpret their environment and make intelligent decisions. And these connecting devices, sensing devices in this way has ushered in the world of Internet of Things and whole new paradigm of business intelligence. There are some myriad differences between the different sensors available to measure virtually everything in the physical world. There are a number of ways to group and cluster sensors into different categories. So we are going to classify these sensors into active or passive sensors. Second one is invasive or non-invasive. Third one is contact or no contact. And the fourth one is absolute or relative sensors. And the area of applications, based on the area of applications also we are going to categorize the sensors. And based on the how we are going to how sensors are measures, based on that also we are going to classify. And what sensors are going to measure, based on that also we are going to categorize the different sensors. Okay, now I'll take the first one, that is an active or passive sensors. Passive sensors. Sensors can be categorized based on their application, okay, based on their usage, okay, whether they produce an energy output or typically require an external power supply, active, or whether they simply receive energy and typically require no external power supply. So we call them as the passive sensors. Okay, those sensors which are going to produce and the energy output and typically require an external power supply, they are called as active. And whether they simply receive energy and typically require no extra power supply, those are called as the passive sensors, which don't require the external power supply. Okay, those we call it as a passive sensors. So active or passive sensors. Next is a invasive and non-invasive sensors. These can be categorized based on whether a sensor is a part of the environment is measuring, we call it as invasive, or external to it, we call it as a non-invasive. Okay, and contact or no contact is sensors can be kept based on whether they require physical contact with what they are measuring, we call them as a contact, or not, then they don't require physical contact, we call them as a no contact. Okay, so contact or no contact, whether you want the physical contact with any device, or they don't want any physical connection. So we call it as a no contact sensors. Next is absolute or relative sensors, and we categorize based on the whether they measure on an absolute scale or based on a difference with a fixed or variable reference value. We call them as a relative sensors. Suppose sensors which are going to use some measurable scales, right? So some absolute scale we call, those sensors are called as absolute sensors. When they don't require the such scale, okay, they will find only the difference with the fixed and the variable reference, their reference value, they we are going to relate it, okay. So they are called as a relative sensors. Based on the area of application also, sensor categorized based on the specific industry or a vertical where they are being used. Okay, area of application, in which area we are going to apply these sensors. Based on that also, we are going to classify whether the sensors are related to a specific industry or they are vertical where we are going to use them in the field. Okay, so how sensors are going to measure? Based on the measurement also, we are going to categorize the sensors. Sensors can be categorized based on the physical mechanism used to measure the sensory input. So for example, if you take thermoelectric and electrochemical, piezoresistive, optic, electric, fluid mechanic, and photoelastic. Okay, these are all. So different way we are going to measure we are going to sense the data from these different devices. Okay, based on now we are going to measure the data with the, so thermoelectric in the form of a heat, okay, electrochemical, so when we are going to pass electricity in the chemical, right, so it is going to sense the data like this, right. So we are going to, based on the measurement of the sensors, we are going to classify that the data is going to be measured, and based on this the sensory data. Okay, so next is what sensors are going to measure. So depending upon the measure, what, based on the applications or what physical variables they measure. Okay, note that this is by no means an exhaustive list, and there are many other classification, so and taxonomic schemes for sensors, which are going to include those based on the material, cost, design and other factors. The most useful classification scheme for the pragmatic application of sensors in an IoT networks, okay, is measuring. This type of categorization is based on what physical phenomenon a sensor is going to measure. Okay, say take sensor type, description, and the example of that. So based on the positions, right, we are going to measure we are going to say till the sensor type. A position sensor measures the position of an object. Say for example, the piston measurement can be either in absolute terms, which is going to use some absolute scale, okay, absolute position of a sensor, or in a relative terms, displacement sensor, position sensor can be linear, angular, or multi-axis. Examples are potentiometer, inclinometer, proximity sensor. Okay. So next is occupancy and motion sensors. These sensors are going to detect the presence of an object. Object may be people or animals in a surveillance area, while motion sensor detect the movement of the people and the objects. The difference between the two is that occupancy sensor generate a signal when even when a person is stationary, whereas motion sensor do not. Example, electric high and the radar. So this application we can apply in the agriculture field. Say for example, any object which is going to enter into a particular field, right? That the sensor device is going to sense the movement of a animal, right? And it going to send a signal to the farmer stating that your agriculture land some object is moving in the field. Okay, so whether it may be the person or it may be the animal or anything which is a living one, because only living things can do the movement, right? So these sensors are going to sense that data and they can signal the that message to the farmer stating that so and so a person is so and so object is moving. Okay, so even you can adopt a video system where that video system can capture the object movement, and even along with the object movement we can send the information to the farmer stating that this is the object which is moving in your particular field. Okay, then velocity and acceleration. The velocity, that is the speed of motion, sensors may be linear or angular, indicating how fast an object moves along a straight line or how fast it rotates. Acceleration sensors measure changes in velocity. So example is accelerometer and gyroscope. So force sensors detect whether the physical force is applied and whether the magnitude of that force is behind the threshold value. Okay. Example for force gauge, viscometer, tactile sensor and touch sensor. Next is a pressure sensor or related to force sensors, measuring force applied by liquids or gases. Pressure is measured in terms of the force per unit area. Example, barometer, Bourdon gauge and piezometer. The flow sensor detects the rate of fluid flow. Say for example, water, oil, milk. Okay, what are the liquid items are there? No. So when the movement start of that liquids, right? This flow sensor detects the rate at which the speed of the flow. Okay. They measure the volume, mass flow or rate, velocity of a fluid that has passed through a system in a given period of time. So anemometer, mass flow sensor, and example is a water meter. Okay, say for example, in your house, if you have the connection, water connection, BWSS water connection, you can speedometer has been installed in your house, right? So if you see that speedometer, we can measure what is the pressure or the what is the force that water is getting into our sump, right? So a fascinating use case of highlights the power sensors and IoT is is in the area of precision agriculture, sometimes referred to as a smart farming, which uses variety of technical advances to improve the efficiency, sustainability, profitability of traditional farming practices. So next is the acoustic sensor type. Acoustic sensors measure the sound levels and convert that information into the digital or analog data signals. Example is microphone, geophone and hydrophone. Okay. Another sensor type is humidity. So it is going to detect the humidity amount of the water vapor in the area of mass, in the air or mass. Humidity levels also can be measured in various ways with the use of absolute humidity, relative humidity, mass ratio and so on. Examples of this humidity is hygrometer, humidimeter, soil moisture sensor. Say for example, we have a sensor which is going to find the humidity or the water content in the present in the soil, right? Which can sense and can give the message whether we can do the farming or not, right? So that is also there is a humidity sensor which is going to find the water content in the soil. Or one more is very important is another humidity sensor which is going to find the fertility of the soil to for the farming, whether the soil is preferable to do the farming or not. Okay. So light sensor another is detect the presence of light visible or invisible. Example, infrared sensor, photo detector and flame detector. Another is a radiation sensor. Radiation sensor detect the radiations in the environment. Radiations can be censored by the scintillating or ionization detect. Say for example, we are going to use the some satellite signal devices, right? Like to catch the phone, to catch the Wi-Fi signals, right? So there are some sensor we can measure what is the radiation of that particular device, right? Whether that radiation is affecting to the human beings or not, or it is affecting to the other living things like birds and animals, right? So like that we have the, the radiation sensors also. Then temperature sensors measure the amount of heat or cold that is present in the system, whether it is in the environment or in the surrounding areas. They can be broadly two types, contact and non-contact. Contact temperature sensors need to be physical contact with the object being you want to measure or sense. Non-contact sensors do not need a physical contact as they measure the temperature through convection and the radiation. Example, thermometer, calorimeter and temperature gauge. Next is the chemical sensors. These chemical sensors measure the concentration of the chemicals in a system. When subject to a mix of chemicals, chemical sensors are typically selective for target type of chemical. For example, a carbon dioxide sensor senses only carbon dioxide. Okay. Take for example, brief laser olfactometer, smoke detector. Then biosensors or detect the various biological elements such as organisms, tissue cells, enzymes, antibodies and nucleic acids. Example, blood glucose biosensor, pulse oximeter, electrocardiograph. Okay. So inside a premier are the technologies which are going to build IOT. Okay. If you want more number of sensors in all shapes and sizes, can measure all types of physical conditions. A fascinating use case of highlight the power sensors and IoT, the area of precision agriculture. Sometimes they referred as a smart farming. So when we are going to use the sensors in our farm, in our agriculture field, we call it as a smart farming. So to find the humidity, water content in the soil, to find the fertility of the soil, a variety of technical advances to improve the efficiency, sustainability and profitability of traditional farming practices, which is going to include the GPS and satellite aerial imagery for determining the field availability robots for high precision planning, harvesting, irrigation and so on. Real-time analytics and artificial predict optimal crop yield, okay, and weather impacts and soil quality.